We ended off by chapter 0,4, which was operations with algebraic expressions, right? So I think we did the simplifying of the plus terms and simplifying of subtraction as well, right? And also removing grouping symbols. And I think that's where we ended off. So now I'll just continue further from where I ended off. And possibly this lesson could be 1 hour, 30 minutes, right? So if you don't have a problem with that, just put a thumbs up. Is that fine if we extend the time by 30 minutes or so, just to make sure we finish everything, right? Or even an hour. What do you guys think? Oh, you guys are fine with us doing this lesson for 2 hours. Okay, perfect. I see that you guys are dedicated. We're gonna get distinctions this year. A lot of distinctions. Okay. Okay, perfect. Yes, it will be on YouTube. I'll send the YouTube link as well when I'm done with the lesson, right? So I ended off by chapter 0,4, and let's just continue further. Oh, damn. Okay, it will clash with the accounting 1A lesson. Okay, so just extend it for 30 minutes, right? So that you guys can just jump to the other lesson. Hi sir, it's my first time here. Welcome. Um, we are just doing chapter 0,4, right? We're continuing from where we ended off, and you can get the lesson on YouTube, right? Okay. Okay, so with algebraic expressions, right, with our operations of algebraic expressions, we have things we call special products, right? And I'm sure that you guys have seen these before. Maybe they use a different term, but I'm 100% sure you guys have seen these before, right? So for example, you have number one of your special products, right? So if I say x multiplied by y plus z is equals to xy plus xz. I'm sure you guys have seen these before, right? This is what we call our distributive property, right? So basically what we just did over here is we took this x and we multiplied it to each of those terms inside the brackets, right? Pretty basic stuff. We've all seen these before, right? Okay, so the second one that we have is, let's say we have two brackets, and inside the brackets we have x plus a, and the other bracket we have x plus b, right? Um, what we can do, or the operation we can do over here, we can simplify this, right? And simplifying this, we use a method called factorization, or some of you may know it as FOIL, right? So foiling basically means that we take the first two, which that's the F, that F stands for that, the outer two, the inner two, and the last two, right? And we multiply them together basically. So let's start off with the first two. So the first two would be x times x, right? Which will give us x squared. And then the second one would be the outer two, which is x times b, which will give us b times x, right? And then the other one would be a times x, which are the inner two. And that will give us ax. And the last two would be a times b, which will leave us with a times b over there, right? So I see we have a full house today. We have a lot of people that are attending. You guys are serious this year, right? And I'm very glad. So let's continue. We can just simplify this further. We have x squared, right? Plus, and then I want you guys to notice something over here. What can we do? If someone can just answer in the chat what we can do over here, just to simplify that, what can we do? What do you guys think we can do? You can just type it in the chat, or you can raise up your hand and answer the question. Okay, let's start off with Kamuhelo. You can answer the question. Okay, I see the people are saying take out the common factor in the chat. That is 100% correct, right? So let's take out a common factor of x, right? And then we would be left with, okay, it's better to write it down this way, right? I'm taking out a common factor of x, and then you know your a and your b would basically be your numbers, right? So I'll write it down as a plus b. That would basically be your constant. So Apumelele, I see you also raised up your hand. You will have the next question, right? Do not worry. Okay, so the next one that we have, the next operation, which is number 3. Number 3 says if we have ax plus c multiplied by bx plus d, right? What can we do to this as well? And I'm here to tell you that we can do the exact same thing. We do the exact same thing. All we have to do is we factorize, right? So, okay, a lot of people want me to admit them, so don't be shocked when I lose concentration for a bit, because a lot of people want me to add to allow them in, right? Okay, so for this case, we can do the exact same thing, right? Nothing has changed. We do the exact same foiling method, and we just take this ax and we multiply it with the bx, right? So that will give us a bx squared. Sure you guys agree with that. And then the next thing we do, we take the outer two, which is this one and this one, right? So that will leave us with, okay, let's put a positive over there. So it's ADX as well. And then we take the inner two. So the inner two is the C and the BX, right? And that will give us a BCX as well. And then the last two would be the C and the D. So that would leave us with the C times D. And then, of course, you can always just simplify the middle term, right? And then I see someone also asked the question in the chat. I'll get to you in a few. Okay. So let's just simplify this. We have ABX squared plus, we take out a common factor of x, right? And then we basically have the AD remaining plus the BC remaining. And then we have that x that we took out, right? And then we have the plus C and D remaining. And that will be our final answer. Okay, so let me check in the chat. Can't we also use 1 over A plus 1 over B? So where are you referring that to? Are you referring it to the question we just did now, over here? 1 over A plus 1 over B. Number two. Okay. Oh, you want me to do the example where we have 1 over A plus 1 over B? I'm kind of lost. An example where we have 1 over A plus 1 over B. Okay, let's do that. So if we have 1 over A plus 1 over B, what do you want us to have for the second bracket? I'll repeat number 3 as well, don't worry. AX multiplied by BX plus D plus C plus BX plus D. Is it okay like this? Okay, I'll also tell you what happens over there. And then Patricia, just please tell me what else you want me to write as the second bracket. Okay, just remember, these are the products, right? These are the laws, basically. I'm still doing the laws. So when we have examples and you would ask me, you would want me to do examples, then I'll definitely do that for you. These are still just the laws. We will head over to the examples as well in a few, right? Okay. So I'll repeat number 3 once more, right? So with number 3, we do the exact same thing as number 2, right? We use the method called foiling or FOIL, right? So the method called FOIL wants us to use the first two. That's what the F stands for. So the first two is AX multiplied by BX. And as you can see over there, we have AB and then we have two X's. So that's why we say X squared, right? And then they want us to use the outer two. So the outer two would be your AX and the D. So over there we have A and D and 1X. And this is what we wrote there. And then we just do that up until we finish the foiling thing, right? The foiling letters. So the next one will be the I, which is the inner two, the C and the BX, and then the L would stand for the last two, which is your C and your D, right? So I'm sure you guys are okay with that. Just put a thumbs up if you are okay with that. Put a thumbs up. Okay, perfect, perfect, perfect. Lucas, I see you raised up your hand. You may ask a question. Okay, seems like that was a mistake. Okay, perfect, perfect, perfect. So let's head over to the next law. So number 4 says if we have x plus a squared, right? This is basically the same as number 2 and number 3, right? Because you can write this down as x plus a multiplied by x plus a. We did this in 0,3. If you guys remember correctly, we did something like this in 0,3, where we said x squared is equals to x times x, right? In this case, they just put something in replacement of the x. And that something is your bracket x plus a. And then they just put the squared. So we do the exact same thing over here, right? So are you guys okay with that? Just put a thumbs up. Okay, perfect, perfect, perfect. I'm glad you guys understand that. So let's move on. So if this is the same thing as number 2 and number 3, what method should we use? That's correct. We need to use FOIL, right? Are you guys with me on this? Another round of thumbs up. Come on, let's go. Perfect, 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 perfect. Okay. So now let's just simplify this using foiling. So I'm sure you guys are okay with me doing this a bit faster, right? I'll just say x squared plus ax plus ax plus a squared, right? And this is equals to x squared plus 2ax plus a squared. Pretty straightforward, right? But don't worry. If you guys are looking for a bit of a challenge, the chapters are coming in a few. Don't worry. The chapters are coming in a few. So if we can just finish chapter 0, and then, yeah, that's when I feel like this module starts getting a bit more difficult, you see. Yeah, so if you guys are looking for a challenge, don't worry. It's coming. Okay, let's move on. Let's move on. So now we have the 5th one, and the 5th one is basically the exact same thing, but with just the minus sign, right? And I'll just do this one quickly because you guys should now be used to it, right? We open the brackets, we write down 2 brackets, then we FOIL, right? So x squared minus ax plus a squared. And that would be it, right? And then we just simplify it, you know, so that we get our full marks. You know, sometimes the lecturers no, it's not a difference of 2 squared as of yet. I'll show you the difference of a 2 squared, right? So don't worry about that. I'll show you the difference of a 2 squared. Yes. Okay. So that's the final answer over there. And let's head over to the 6th one. So the 6th one, we have x plus a, right, multiplied by x minus a. And someone in the chat just said what this was, right? And how do you identify what this is? As soon as you see a positive in one bracket and you see a negative in the other bracket, then that's when you need to know that that is a difference of two squares. It says in the name, right? Let's just use the name. It says in the name, right? Difference of two squares. Like just try to remember it with that name, right? Even though it doesn't necessarily mean that, I just remember it that the symbols must be different. Hence the name difference for my brain to process it, right? Okay. So what happens over here, right? When you try to simplify the difference of two squares, you do the exact same foiling method. So your foiling method would be x squared, right? And then you take the outer two, which is negative ax. And then you take the inner two, which is positive ax. Then you take the last two, which is negative a squared. So what happens over there is that these cancel out. And then you now have x squared minus a squared. And that's how you know that is a difference of two squares, right? Or a difference of squares. Are you guys okay with this one? Perfect, 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 perfect. Okay. So it seems like you guys, are okay with all of this. Um, I would also like to give you guys homework in the last 15 minutes of this lesson. You will do the homework, you will send it personally to me, right? You will send it personally to me. I will mark it and I'll give you feedback, right? Is that okay with everyone? Okay, perfect. Do we always check the two middle numbers first? So do we always check the two middle numbers first? So I'm assuming that you mean these numbers. Are these the numbers that you mean? These ones? Just put a thumbs up. Do we always check the two middle numbers first? Okay, so there are examples, right? Maybe they will give you something like this, right? And then, yeah, you just have to identify that it's a difference of two squares. But usually they give you in this format, right? They give you in this format. So in the future examples, right, we would have to reverse this format back into that format. Do you see what I mean? Or they'll give you in this format, and once you identify that the two symbols are different, right? The one has a positive and one has a negative, then that's when you need to know that it's a difference of two squares. And then for this one, how do you identify that it's a difference of two squares? You have a negative in the middle, right? And then your first number is a squared, and then of course the negative that I just said, and your last number is a squared, or it is squared as well, right? So that's how you identify that this is a difference of two squares. Are you guys okay with that? We will do examples. Don't worry about that. We'll do examples so that you guys can practice and get better at identifying it, right? Okay. So let's move on to the next what do you call it? To the next special product. So we have number 7. We're almost done with them. And then once we're done, we'll do a couple of examples, right? Okay, so the next one, we have a cube of a sum, right? Cube of a sum. So cube of a sum is the one where they say x plus a to the power of 3, right? So a lot of people don't really like these ones, especially, yeah, like a lot of people don't really like these ones, but they are actually quite simple. All you have to do is you just open 3 brackets, right? Just open 3 brackets. Now, when you open 3 brackets, you just say x plus a, and another x plus a. And then guess what? You just have to simplify all of these. So simplifying all of these, you first start off with these 2 brackets, and you do the normal foiling method. Are you guys with me? Perfect, perfect. So the first bracket, we can leave it out. And then let's do the FOIL on these two brackets. So we basically have x squared plus 2ax plus a squared. All right, that's when you simplify everything. You've done all your FOIL and you've also simplified the middle term. This is what you should get. Are you guys okay with that? I'm just trying to, move a bit faster so that we can cover a bit more topics. Okay, perfect. You guys are fine with that. So what happens now after we reach this point? That's pretty simple. We just multiply these two brackets together. That's it. That's it. That's all we do. Just multiply the two brackets together. And how, you may be asking? You may be asking yourself, how do we do that, Mr. Boost? It's a pretty simple process. You just take the first term of this one, you multiply it to each of the terms in that second bracket. So let's do that, shall we? And I'll do it just beneath over here. So we have the first term of this bracket multiplied by x squared. That's going to be x to the power of 3, right? I hope you guys don't say something like 3x squared, right? Please don't ever make that mistake, right? So it's x to the power of 3. And then the first term of this bracket and the second term of this bracket, that's going to leave us with a 2ax squared, right? And then the last one, which is this x and this a squared, so it's going to be a squared x, right? And then we are not done yet. What happens to this a as well? We do the exact same thing with the a. We multiply it with the x squared, we multiply it with the 2ax, we multiply it with the a squared as well, right? So a multiplied by x squared, that's just ax squared, right? A multiplied by 2ax. So that's going to leave us with 2a squared x. And then the last ones, it's a multiplied by a squared. So that will be a to the power of 3. And then, of course, we just have to simplify it further, right? And then we are done. So let's look for like terms over here. The x to the power of 3 doesn't have a like term. This should definitely have a like term, and it has a like term with the x squared over there, right? So the x squared and this x squared, they are like terms. And then we have this x, which is a like term with this x as well. And then, of course, this one does not have a like term as well. So we just add the like terms together, and we are basically done with that, right? So x to the power of 3, we leave it as it is, plus 2ax squared, plus ax squared, that is 3ax squared, and then a squared x plus 2a squared x is 3a squared x, and then we just write down the remaining a to the power of 3. So hit me with some thumbs up if you guys are okay with this. Do we then factor out 3? So it becomes 3. Okay, sorry, let me just check the chat again. So your Patricia is asking if we factor out a 3. Okay, so in this case, right, we were simplifying, right? So you do not need to take out the 3 because each of these terms do not have a 3. So if it was something like this, right? If we had 3's in each of these terms, then that's when we could take out a common factor of 3, right? And then we would have these parts remaining. But since we do not have a 3, we do not have to take out a common factor of 3. Likewise with your x, you cannot take out a common factor of x because there's we have an x over here, we have an x over here, as well as over here, but we do not have an x in this last term. So we cannot take out a common factor because it's not common in all terms that we have over there. Okay, so for 3ax squared plus 2x, 3a to the power of 2x. So power of 2 and x. So you mean for the middle parts over here. It's up to you for that one. You can definitely do that if you want to. That's definitely up to you. You can write it as x to the power of 3 plus 3ax squared. Or actually, let's take out a common factor of a as well. It's up to you, but you don't necessarily have to. You can just leave it as. You can just leave it like this if you want to, right? But you don't have to factor it out, and preferably don't factor it out. You know, there's no need to. Okay, so let's head over to the last law. And the last law is the exact same thing, guys, but they just put a negative symbol over there. So do you guys see it? Is it necessary for us to go through it? Because it's the exact same thing. We do the exact same steps, but they just put a negative symbol over there. Right? We'll be doing too much now. We'll be doing too much if we were to go through this, fully again. But just remember that you just open 3 brackets, deal with the first, with these 2 brackets first, right? And then you do the last bracket as well. And then you just simplify everything and you're done. Okay, so shall we go to examples now? Or do you guys have any questions? Okay, so it seems like you guys are fine with all of this. So this means that we can now go and do a couple of examples, right? Okay, perfect. So the first example that I would like to do with you guys is I'll head straight to the difficult examples, right? Because in the exam or the test, they usually don't give you easy stuff, right? So of course, I would prefer you guys to do the most difficult stuff so that the easiest stuff become easy to us. So that the medium and the easy stuff become a breeze to you, right? So let's go. Let me look for an example. Okay, here's an example, a nice example for us. Okay, so we have the square root of y squared plus 1. And then they add a 3 to it. And then this is multiplied by square root of y squared plus 1 minus 3, right? So what do you guys think we need to do over here? Let's hear from the chat, or you can raise up your hand and answer and answer yes, what you think we need to do over here. Okay, I see. Let's give Apumelele a chance. I see he or she raised up their hand for a very, very long time. Foil, okay. Distribute, okay. Anyone else? Foil, okay, perfect, okay. And then, okay, difference of 2 squares, okay. None of you guys are incorrect, right? So how this is gonna be a difference of 2 squared, right? I'm glad you were able to identify identify this. But yes, of course, in order for us to simplify your difference of 2 squared, no, sorry, this is not a difference of 2 squares. Sorry. Remember, with the difference of 2 squares, we need to have, like a squared something over there, so that you can do a difference of 2 squared. But it will technically come out, to a similar answer or something like that. So we just need to FOIL over here. And foiling, we multiply the first 2 together. So that will give us a y squared plus 1. And why is that? That's because when we multiply 2 square roots together, they cancel out, right? Same thing when we multiply a cube root with each other, the cube roots will cancel out, right? So as long as these things are the same and you're multiplying them and you have the same base, they will cancel out. Well, you don't necessarily need to have a. Okay, yeah. So they'll cancel out if they have the same base. Okay. So the first two, we have y squared plus 1, and the roots cancelled out. And the last two, we have a negative 3 square root of y squared plus 1. And the inner two, that's a positive 3 root y squared plus 1. And then the last two would be a negative 3 times 3 is 9, right? And that's it. And then we just cancel this out. Pa, pa. And then we can simplify this. So simplifying this, we have the y squared plus 1 minus 9 remaining. Then what happens over there? We just simplify. And this would be our final answer. And we are done. Are you guys okay with this? Should I give you guys a more difficult one? Okay, bravo. Okay, proper. I'm glad. Okay, so let's look for, one more example. And then maybe after this, we can head over to, your dividing a multinomial with a monomial. Then. And then also long division. All right. So I think a lot of people apparently have, a problem with long division. Don't worry, I'll teach it to you guys. And you will always get full marks for it. It's always 5 marks in your test, right? Always 5 marks. So those are easy 5 marks you can always get, right? Okay. So let's do maybe 1 or 2 more examples. Okay, let's do this one actually. And then someone also asked the question in the chat, can we leave it as 2 to the power of 3? 2 to the power of 3. There's no need to do that, but you're not incorrect when you write it like that. But there is no need to do that. And remember, please don't do unnecessary stuff, because you have a limited time frame in your tests and your exams. And you don't want to waste it on doing stuff that is not necessary, right? Okay, so let's do this example, and then we will head over to the the divisions part, right? Okay, so we have this over here, and they just want us to find the product of this expression given over there. So someone raised up their hand. Let me just check who it is. Panuel. So Panuel, you may ask your question.
No, sir. I want to answer the question.
Oh, you want to answer the question? Lovely.
Yes, sir.
Okay, let's go. So tell
It's
me,
gonna
are you gonna
be
tell me, sorry, are you gonna tell
it,
me the final answer, or are you gonna tell me like step by step?
step by step, sir.
Okay, proper, let's go.
It's
So,
gonna be equals. It's gonna be equals to 10t cubed plus 6t squared minus 2 minus 15t squared minus 9t plus 4. Then it will give us, then we're gonna group like terms. Then
sorry,
10t
did you say
squared,
plus 4?
say,
Did you say plus
plus,
4 for the last one?
yes, say.
Okay.
Then
And then,
we're gonna group like
Sorry,
terms from here.
sorry.
yes.
Can I ask something? Sorry to disturb.
Okay, not a problem. Shoot.
Okay, so he said 2 multiplied by 5t squared is 10t3, right?
Okay, 2 multiplied by,
5t squared is
okay,
10t. And the next
2t,
he said t is 2t multiplied by 3t gives 6t squared, right?
okay.
But why did he say?
Oh, okay, yes. So for the last one, right? For the last term, it's supposed to be a 2t over here. So maybe I didn't hear
yes.
him when he was saying it, right? So yeah, it's supposed to be like that.
Then the final answer is 10t cubed. 10,
Okay.
10t cubed minus 9t squared minus
Sir,
11t plus 4.
sir, isn't it supposed to be plus 3?
Okay, so yes, also that's another mistake that he did. So this is supposed to be +3, right? So I think
Wait,
he might have maybe just tried added this by mistake. So this would give us a +3 as the last term, right? Because it's -3 multiplied by -1. So does everyone agree with
yes,
this?
yes, yes, yes,
Okay, maybe I didn't hear you. So okay, but everything
yes,
looks
sir.
fine. Well done, well done, well done. So everything looks fine. Thank you for
It's fine.
answering. So yeah, I think you guys are sorted with this chapter. All right. So let's go over to dividing multinomials with monomials, right? And that this would be the easy division, right? The easy division that we are used to. And then we will also head over to the long division type of questions. Okay. So let me just quickly write down. So this is called dividing multinomial with monomial. And basically what this means is that in your numerator, right, you will have multiple terms. And then in your denominator, you'll be dividing it with a denominator that only has one term, right? So this is basically division with one term. Guys, this is very important. Division with one term. Please don't forget this. Okay. So let's do an example. We have x to the power of 4 plus 9x to the power of 5. Okay, no, actually, let me just write x to the power of 2. And then let's say negative x, and then maybe a plus 5, right? This is divided by, let's say, x. So I'm sure you guys are familiar with this one. This is the division where we divide with each term individually, right? So the first term, dividing the first term, will basically have x to the power of 4 divided by x. Then dividing the second term, we'll basically have that 9x squared divided by x, right? And then the next term, dividing it, we would have x divided by x, right? And then the last term, we would have a 5 divided by x. So are you guys okay with this so far? Okay, perfect. And then what happens over there? We cancel this. We cancel one of the x's. Cancel one of the x's over there. This x will cancel with that x over there. And then the last term, we can leave it alone because the x will not cancel with anything. Okay. So x to the power of 4 divided by x will let us remain with an x to the power of 3. 9x squared divided by x will let us remain with the 9x. X divided by x will let us remain with a -1. And then the last one would be just the 5 divided by x. So let's hit some thumbs up if you guys are fine with this, and then I can head over to the next part, which is long division. So this one is very simple, guys. I'm sure you guys have done this multiple times. And the way you identify it is if we have one term, and that's when we can do this. If we have one term in the denominator, we can always do this, right? Always, guys, always simplify it like this. And then now what happens when we have more than one term in the denominator? When we have more than one term in the denominator, we do something called long division. Right? And when we have something like this, these are usually 5 marks. All right, these type of questions are usually 5 marks or 6 marks even. So please, 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 guys, listen carefully to what I'm about to say with these ones, right? Make sure you understand it. And if you guys do not understand it, we can go over it 100 times even, right? I do not mind. I just want to make sure that you guys understand this, right? Okay, so Precious, is it Precious? No, it's not Precious. It's Asakanya. Aren't we supposed to change the 5 divided by x to be 5x to the power of -1? You can definitely do that as well. That is up to you. But technically, we do not like dealing with negative exponents as our final answers, right? It's good maths manners to always write down our answers as positive exponents, right? So you can write it down like that. They will not make it incorrect, right? But just always try to leave it as positive exponents. Okay, so with our long division, what are we looking for? We're looking for, let's just say one thing only. Just looking for one thing only, right? Or actually, no, 2 things. And then the second thing I'll tell you as we head forward, right? So the first thing that we're looking for is multiple terms in the denominator. And the second thing that we are also looking for, right, is if the numerator's degree is greater than that of the denominator. And what do I mean by that? Let me show you. So let's say we have an example that says, x to the power of 2, right? Minus x to the power of, minus x plus 4. And this is divided by x to the power of 3 minus 4, right? We have a problem over here, and we cannot perform long division when we have something like this. And that will be due to the second thing that we are usually looking for when we do long division. Actually, we always need to look for it. If the numerator's degree, as you can see, this is the numerator's degree. The highest numerator's degree is x to the power of 2. It has to be greater or equal. Let me just write that down. Greater or equal to the denominator's degree in order for us to perform long division. Are you guys with me on that? So if this was x to the power of 3, we would be able to perform long division. But the moment it becomes less than the denominator's degree, so x to the power of 1, x to the power of 2, then we cannot perform long division anymore, right? You just leave it as it is. Even if it's a 5-mark question, just leave it as it is. Okay. So let's do an example. And let's say 2x to the power of 3 minus 14x minus 5. And we are dividing this by x minus 3. Okay. So of course, you guys are familiar with this funny symbol that we use when we do long division. And where do we place the stuff, right? We place the x minus 3 on the outside, right? 2 years ago, I was tutoring some students, or a whole group of students, and I kept on telling them, guys, all right, that's the divisor This is the divisor, right? The thing we're dividing with, right? I kept on telling them the divisor must go on the outside. And then they got an example that looked a bit weird, a question that got a bit weird, that looked a bit weird, sorry. And then they decided to put this whole thing over there. And they got the whole question wrong, right? So please don't make that mistake. Never, no matter how the question looks, don't ever do that, right? I'm telling you guys this now. I'm telling you guys this now so that you don't make that mistake ever, right? So the divisor goes on the outside, and then the dividend goes on the inside. So 2x to the power of 3 minus 14x minus 5, right? And then
Sorry.
Okay,
Sir,
yes.
I'm not sure if I understand. Where did you get, in fact, where did you divide x minus 3? Where did you get it?
Where do we get it? So the question will tell us that, they'll just tell us divide. This is what the question literally says. Divide 2x to the power of 3 minus 14x minus 5 by x minus 3. That's what the question just told us.
Okay,
Yeah.
thank you.
Okay, our pleasure. So let's move on. Okay, so we have ticked all these two things that we need. We see that we have multiple terms in the denominator. We also see that our numerator's degree is greater or equal than that of the denominator. Then we are 100% sure that we can now perform long division. So a lot of people like doing that way of daddy, mommy, sister, brother, right? I don't know. I just don't like that method. I'm just gonna show you the method that I like doing because it's quicker and straightforward, right? Don't have to remember any funny acronyms. Are you guys okay with learning the new one? Or do you guys want us to use daddy, mommy, sister, brother? No. It's not BODMAS. It was DMSB. That is the acronym that they used to use. But we basically just do the exact same thing. But I just don't like, writing down the DMSB every single time, right? Rephrasing it every single time. And yes, Patricia, let's do it like that, actually. Thank you for reminding me. So I'm going to write down a 0x squared and then minus 14x minus 5, right? And the reason you do this is because it makes it easier for you to visualize things, right? You would make a mistake if you did not place this one over there, right? So just write the 0x squared. It does not change your expression because this is technically just a 0, right? So it does not change your expression, but it's best to always put it there, right? If you have a missing term or degree over there. Are you guys okay with why we put the 0x squared before I do the whole thing and then someone asks a question? Okay, Nzagelo, I see you raised up your hand.
Sir, I just wanted you to clarify something for me. So you
Okay.
say that we can put the 0, like even if maybe the x cubed was not there, we can put a 0.
Okay, so if the x cube wasn't there, then there wouldn't really be a need for you to put it there, right?
Oh, okay.
But
So when do we
then,
put it?
okay, yes, perfect. So in this case, right, as you can see, we have these powers are descending. We have x to the power of 3, and then it just jumps to x to the power of 1. So that's what we don't want, right? We want it to, x to the power of 3, x to the power of 2, x to the power of 1, and then x to the power of 0 over here. You see, so we want to, write it down like that.
Oh, okay.
Okay. Okay, so the person, so please, the person is singing, please just mute your mic. Okay. Let's continue, right? Okay. So what we need to look for as we start this thing, right? So we need to look at the first terms of these two things, right? So over here in the first term of the 2x to the power of 3, this is the first term, right? And then this is also the first term of the denominator, all right? All we need to do is we need to take this x over here and divide it. And once we divide it, the answer of this, we write it at the top. So this would leave us with the 2x to the power of 2. Are you guys okay with that? Okay, lovely. Lovely, lovely. And then I'm just going to erase this part. And then what am I going to do after that? Pumelele, I see you raised up your hand if I'm not mistaken. Okay, perhaps it was a mistake. So it's the 2x to the power of 3, right? Which is the first term of the numerator, right? So basically, if we write this thing down as 2x to the power of 3 minus 14x minus 5 divided by x minus 3, we are only looking at the highest term. So the first term, this one, for the numerator and the denominator. Are you guys okay with that? Okay, perfect. And then I'll take this x, I'll divide it with the 2x to the power of 3. The exact same way this has been divided like this. I'll divide it exactly like that. Do you see it? So those arrows that I just wrote down there, I'll divide it exactly like that. And when I divide it, what happens? I get 2x squared as the answer. So we'll go through this step by step. This is a very important question. Are you guys okay with this? So for those who used Daddy, Mommy, Sister, Brother, we have just done the division part of it, right? And then once you're done with that, once you have this 2x squared, what I would like for you to do now is I would like you to take this term and multiply it into each of these terms. So when you do that, what do we have? I'm sure you guys, we will just do a side calculation. We would have 2x squared multiplied by x minus 3, right? And we just multiply the terms inside, right? And multiplying the terms inside, we would basically have 2x to the power of 3 minus 6x squared. Do you guys agree with me on that? Okay. And this answer that we got when we multiplied everything inside, right? This is the answer that we will write down over here. Do you guys see it now? So are you guys still with me on this? Okay, perfect. And the reason why we wrote down the 0x squared is because we do not want to minus this one and this one by mistake. So we want to minus the x squareds together. That's why we write down that x squared, 0x squared. And then remember, we need to now subtract. So we subtract, let's just put a negative symbol at the front. So we subtract these things. And subtracting them, what do we now have? We have the 2x to the power of 3, right? 2x to the power of 3 minus this minus 2x to the power of 3. That will leave us with a 0. Do you guys agree with me on that? I'm going to go through this very slowly, guys. Don't worry. And then this negative symbol, when we also multiply it over there, what happens? It changes to a positive, right? So we technically have 0x squared plus 6x squared. And then we are done. And then the last thing we just need to do is we just need to bring down this thing. So bringing it down, we have negative 14x minus 5. Are you guys okay with this so far? We're not done, but you guys okay with this so far?
Can you repeat?
Okay, which part do you want me to repeat?
Like the
Zero.
the
Where's
two,
zero coming from?
Sorry?
repeat from 2x cubed minus 6x squared.
2x cubed minus 6x squared. So from here, basically.
Yeah.
Okay, so how we got to that, right, is how we got to that is this 2x squared that we got originally from the start, right? Remember, when we divided these two together, we multiplied this 2x squared with the x minus 3, which when we simplified, this is what we got. We simplified it on the side, right? This is what we got. And then we just put that answer in brackets underneath this part so they just match up, as you can see, right? And then we put a negative symbol at the front so that we can subtract this part with this part as well. And that gave us 0 plus 6x squared. Are you with me on that?
Yo,
Okay.
I'm still confused.
You're still confused. Which part is confusing you? Is it the
Like
same part?
0 plus x squared. Where does the plus come from?
0 plus 6x.
Yeah, like I want to know where does the plus come from?
So this plus basically.
Yeah.
Okay, so remember when I put this negative symbol at the front, based on my, this DMSB thing, I need to subtract these two terms, these two things that I got, right? I need to subtract them together. And when we put a negative symbol in front of a bracket, we need to multiply the negatives inside. So that's why we have the 2x to the power of 3 minus the 2x to the power of 3, and that gave us the 0. And then this negative multiply with the other negative, and it gave us a positive 6x squared. So that's how we got to the positive. Okay, so you guys are putting up the thumbs up. So I'm assuming that you guys are fine. Then someone asked, don't we only bring down the negative 14x? You can do that if you want to, but I just prefer to take down everything, right? So that it just makes my life easier. Okay, so now we are still not done with our question over here. We are still not done. Okay, so now what do? We do the exact same thing. We look at the first two terms, right? So this is what is remaining in the numerator. This 6x squared minus 14x is what is remaining in the numerator. And I would now like to divide the first term, the first highest term, which is the 6x squared, with this x as well. So we are doing the exact same thing again. And once we do that, what happens? We have the 6x squared divided by our x. And of course, the answer would be a positive. It will be a positive 6x. Are you guys with me? Okay, perfect. And then likewise, we take the 6x, we multiply it to that x and the negative 3 over there. And then I'll just do the calculation on the side of that multiplication, right? So we have the 6x multiplied by our x minus 3. So simplifying this is 6x squared minus 18x, right? And then I'm just going to write this down underneath over here. So 6x squared minus 18x. Then do not forget to put your negative symbol at the front of that bracket, right? And then we do the exact same thing now. So we multiply this negative inside. So we'll have a negative 6x squared and a positive 18x. Okay, so let's minus the two together. So we have a 6x squared minus 6x squared, so that's 0. Negative 14x plus 18x. That's going to leave us with a positive 4x. Then what do we do over there? We bring down the negative 5. And then I have one more question to ask you guys, can we perform long division? Can we still perform long division in this case?
Yes.
Okay. So for those who are saying yes, what would be the reason?
No.
Okay,
yeah.
so
X.
for those who saying no as well, what would be the reason?
I'm saying yes.
Yes.
Yes,
Yes.
because we still have an X
Okay, so
coefficient.
Mayban, or I'm
Yes.
not sure if I'm pronouncing your word correctly, right? Mayban or Mayban, right? He has said the correct thing, right? We still have equal degrees in the numerator and the denominator, right?
Mm.
So we can still perform long division. So this is the equal degrees, right? So we can still perform long division. And we do the exact same steps that we did. So I'm going to take this x, I'm just going to divide it over here. And then what do we have? We have a plus 4 when you divide these two, right? Then let me just erase this. So what happens now is I'm going to take that 4 and I'm going to multiply it into the x minus 3 over there. So this one will be quick, right? I can just say my bracket would be 4x minus 12. Are you guys with me on that one? And then just please tell me, what am I forgetting?
Minus.
The minus. Perfect, perfect, perfect. You're forgetting the minus. So with the minus, please don't ever forget it, guys. The moment you forget it, you may do your things incorrectly, right? So I'm just gonna multiply this negative inside, and this would change to a negative 4x, and this would change to positive 12, right? And then let's write down our final answers. Let's finish everything down, right? So we have the positive 4x minus the 4x, that's a 0. And then we have the negative 5 plus 12. That would be 7, right? It's a positive 7. And there we go. We are done with our long division. So we just need to now write down the final answer. And always write down the final answer, or else you will not get your full marks, right? So what does our final answer consist of? So I'm sure you guys have been wondering why we are writing this down. I hope you guys are not thinking that we have just been writing this down for no reason, right? This actually goes to our final answer. So our final answer will consist of the 2x squared plus 6x plus 4, right? Plus the 7 divided by our divisor. Remember, this is what we call the what do you call it?
The remainder.
The remainder, yes, the remainder. So it remains in the numerator. So can you also please show us the synthetic method to verify our answer? So with the synthetic method, you do not need to do it. I don't think they're gonna give you full marks if you do the synthetic method as well. So just leave it as it is and do this method instead.
So, say, is it necessary to write all the zeros?
Is it necessary to write down all the
zeros.
zeros? These ones, no, there's no need to write down all those zeros.
Okay.
Yes. Okay, so perfect. It means we are done with long division, Mus. Oh, another example. Okay, let's do another example. I wanted to do questions, but okay, let's do another example. In either way, you may ask your question. So this is the last example we'll be doing, and then I'll give you guys what do you call it? I'll give you guys examples to do, right? Sorry, I'll give you guys homework. Yes, homework. Okay, Renelia, sorry for cutting you off. You may ask a question.
So I wanted to ask that with the next question, can you give it to us so we can try it by ourselves?
Okay. So if I'm to give it to you guys, I would expect you guys to finish it within 2 minutes. Is that fine? Just put a thumbs up, everyone. So that you guys will do it in 2 minutes. Then we'll go through it together. We'll still go through it together. So it's also just gonna be practice for you guys, Jake. Okay, I see some thumbs down. So it seems like people are not happy with that. Maybe let's do one more. Let's do one more, and then and at 15 past, that's when we're gonna do what do you call it? At 15 past, we'll do I'll give you guys questions to do. Okay, so let me look for one more example. Or let me look for one more question actually. Perhaps maybe I should just look. Don't worry about the time. Don't worry about the time. This is just the last thing. I'm trying to look for a question that we can do. Okay, so here's a question that we can do. We have, what do you call it? X squared. Okay, let's do it like this. So x squared divided by, what is that? Okay, x plus 2. Okay, it's x to the power of 3 actually, divided by x plus 2. So here's a long division type of question. And how do you identify it? You can see that in your denominator, you have 2 terms, right? That's how you identify that you need to do your long division. And then you can also see that in your numerator, you either have a degree that is greater or equal to the denominator's degree. And then let's start. So I'm just gonna draw this thing over there. So inside, this is the type of question that kind of actually disturbed the other students, right? They saw something weird in the numerator and it wasn't working out, right? It was a long question. And then they wrote the x to the power of 3 on the outside. So just please always write the numerator in the inside and the denominator on the outside. And then we do the exact same thing. We take the x to the power of 3, we divide it with this x. So that will be x to the power of 2. Right? We divided this x to the power of 3. So I'm just going to move a bit faster so that we cannot lose time, right? And I'm going to take this x squared, I'm going to multiply it to that term over there, to those 2 terms over there, right? So that will let us remain with x to the power of 3 multiplied by 2 x squared, right? And this is why we should always write down the 0 x squared so that we can see what we are minusing with, right? Let's not forget to put the negative symbol. And then let's finish, let's tidy everything up now. So now we have the negative over there. When we multiply this inside, we also have the negative when we multiply the negative inside over there. So x to the power of 3 minus x to the power of 3, that's just a 0. 0x squared minus 2x squared, that will leave us with a negative 2x squared, right? Just put a thumbs up. You guys okay? Okay, seems like you guys are okay with everything so far. Let's carry on. So now we do the exact same thing, right? We take this x, we divide it with the negative 2x over there. And that should give us a negative 2x, right? And then I'm going to take this negative 2x, I'm going to multiply it over there. So don't forget to multiply it with a negative 2x. So multiplying that with a negative 2x, I should get negative 2x squared and then minus 4x, right? And let's not forget to put our negative symbol over there. When we multiply the negative symbol, we get a positive 2x squared and a positive 4x. And this is divided by, so not divided. So when we simplify this, we basically just get a negative 2x squared plus a 2x squared, right? So that's just the 0 as well. And then we have our a positive 4x. And there's basically nothing it's adding to, right? So we'll just leave it as a positive 4x. And then we do the exact same thing one more time, right? Because the degrees are the same in the numerator and the denominator. So I'm going to take that x, I'm going to divide it over there, and then I just get a plus 4, right? So once I get that plus 4, I'll take it and multiply it to each of those terms. And when I multiply it to each of those terms, what do I get? I get a positive 4x plus 8, right? And let's not forget to put a negative symbol at the front. And then likewise, we will also multiply our negative symbol inside, and this will leave us with a negative 4x and a negative 8x. Remember, over here, this is a plus 0, right? So you don't necessarily also have to write it down and just leave it as it is, as long as you know that there's a 0 over there, right? So positive 4x minus 4x, that's just going to let us have a 0. And then we have a 0 minus 8. And that would be our remainder. So simplifying everything and writing down our answer, this would be our answer. And this part, right? So x squared minus 2x plus 4 minus, because of that minus on the front of 8, 8 divided by our divisor, which is x plus 2. And that will be our final answer and 5 marks. Are you guys okay with this? You can just put a thumbs up. Okay, perfect. So from now onwards, guys, we will be splitting the classes, right? Okay, so let me just repeat that. We'll be splitting the classes, right? The introductory mathematical analysis classes will attend on their own. The extended students will attend on their own, and the business mathematics students will also attend on their own, right? Because now things are gonna start moving at a different pace to each other, right? So I'll announce everything on the group chat. Don't worry. And also this lesson recording, you'll find it on YouTube, and I'm gonna write it down. I'm gonna write down the YouTube channel in the chat now, right? So just search it up and subscribe, and please like, right? Okay, so let me give you guys the homework that I want you guys to do, right? Okay. So I'll give you guys 5 questions to do, right? I'll give you guys five questions to do. My pleasure, Kimberly. Okay, so let's start off with number 1. I'll give you guys, quite a simple one. Let's say the square root of x plus 2 root x plus 3 root x plus 4 root x. So that's the first one. And the second one that I would like you guys to do. And I also just like to give you guys a difficult one, maybe a difficult simplifying one. But it's okay, maybe let me leave you guys for now. I'll give you guys in the next one, right? And then let's choose this one as well. Okay, so Tabang just sent the lesson link, sorry, the YouTube channel link, right? On the, what do you call it? on the chat. So you can just copy that link and paste it down, right? And then subscribe, please, guys. Subscribe so that you do not miss valuable information, right? And valuable work. And then we also have this example. And then our last one. The last one I would like you guys to do as well would be another, what do you call it? Another long division question, right? So x to the power of 4 plus 3x squared plus 2 divided by x plus 1. So the only challenging one should be this one, right? Maybe you may make a few mistakes, but all of them, I want you guys to get all of these ones correct. Then all you have to do is just have to simplify, right? So simplification. Okay. So please do all of these and send me the answers, right? And then I'll tell you guys if you're correct or not, right? You can either send it on the main, I'll actually give you guys the numbers you guys can send on, right? And then are the 2s, 3s, and 4s roots or coefficients in the number? Oh, they're coefficients. Yes, they're not roots, they're coefficients. So these ones, if you guys are lost as to what the person in the chat is referring to, these are coefficients. They are not roots or root numbers, right? Okay, so thank you guys for attending. This is the end of our lesson, and I wish you all the best for the next lesson as well. Have a great night.
I'm sorry, before we finish, I have a quick question. Can
Okay.
you just quickly go over number 2? I think the brackets there are a bit confusing. I don't know if you were meant to say 2u squared and then multiplying into the bracket, because there's just many brackets on the second part, like after the
So-
minus sign.
So over here.
Yeah.
Okay. Yes, that's the one that I mean. Just it's like that. Let me see if the brackets are matching though.
Yeah.
Maybe there's one more bracket that I need to put in, sorry. Okay, so there's one more bracket that I need to put in. Let me actually do it like this so it doesn't confuse you. Let me use different brackets. Is this better?
Okay. Yeah, it makes sense. Thank you.
Okay, pleasure. Where do you submit the work? You submit it. Please send it to me, personally to my numbers. And I'll also send you guys the other numbers that I can that you can also send the work to. Right. So just send it to those numbers, and then yeah, we'll tell you if you're correct or not. Okay. So thank you guys so much, and have a great night.
Thank you.